بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. And these are some exercises about section 5.5. Here evaluate the integral by making the given substitution. So u is given, so immediately I need to find du. So du would be the derivative of x squared, which is negative 2x times dx. Now if I go back to the question, I have x multiplied by dx, but I need negative 2. So I will multiply outside by negative 1 over negative 2, inside by negative 2, x e to the power negative x squared dx. And now I can change the integral from x to u. So negative 2x with dx is called du, and I have e to the power negative x squared, which is u. So the integral would be e negative half. Integral of eu is eu plus c. And now the final answer would be negative half e to the power. And I put the value of u, which is negative x squared plus c. If you want to check your answer, find the derivative of this. You should get x times e to the power negative x squared. U is x cubed plus 1. Du would be the derivative of x cubed plus 1, which is 3x squared dx. I have x squared dx, so I need 3. So I will divide outside by 3, inside multiply by 3, 3x squared, and I have the root dx. So changing to x, changing from x to u, 3x squared dx as du, and square root x cubed plus 1 is u. To find the integral of this is u to the power half, so the integral is u to the power 3 over 2 over 3 over 2, or times 2 over 3 plus c. So the final answer would be 2 over 9, and I replace u by x cubed plus 1 to the power 1.5, or 3 over 2 plus c. U is sine theta. Du would be the derivative of sine theta, which is cosine theta d theta. Well, I have cosine theta d theta, so this is du, and I have sine theta to the power 2, so this would be u squared. So the answer would be u3 over 3 plus c, and u is sine theta, so 1 over 3 sine cube theta plus c. U is given, du would be, the derivative is 4x cubed dx. I have x cubed in the integral, so I need 4 here. So I divide by 4 outside. So I will have 1 over 4 integral. 4x cubed dx is du, and x4 minus 5 is u. So the answer would be ln absolute value of u plus c, or instead of u, I write x to the power 4 minus 5 plus c. U is the radicand, 1 plus 1 over x. So du would be, the derivative of 1 is 0. The derivative of x is negative 1 over x squared dx. I have 1 over x squared. I need negative 1 over x squared. So I multiply inside and outside by negative. So now negative 1 over x squared times dx is du, and square root of u. Square root of u is u to the power half. So u to the power 3 over 2, and here 2 over 3 plus c. So the final answer would be 2 over 3, negative 2 over 3 times u, which is 1 plus 1 over x to the power 1.5 plus c. U is square root of t, so du would be the derivative of square root of t. I have square root of t in the denominator. I need 2. So 2 in the denominator, so I'll put 2 in the numerator outside. So I will have 2 integral. Now this would be cosine square root of t is u, and 1 over 2 square root of t times dt is just du. So this would be 2 times integral of cosine is sine, and I can replace u by square root of t, and that would be the final answer. Evaluate the indefinite integral. Well, I'll take u, the denominator, I'll call it u. So du would be 4, the derivative of 4x is 4 dx. I have dx, I'll multiply by 4 outside and inside the integral. So 4 dx is now du, and 4x plus 7 is u. So the answer would be ln absolute value of u plus c, or ln absolute value of 4x plus 7 plus c. I'll take u again, the denominator. So the derivative would be derivative of 1 is 0, derivative of sine is cosine. I have cosine theta d theta, so this would be du. 1 plus sine is u, so it would be ln absolute value of u plus c, or ln 1, u is 1 plus sine theta plus c. Again, the denominator, I'll call it u. The derivative is 3z square dz. I have z square, I need 3. So it would be 1 over 3 times 3z square dz is du, and this is u. So I have ln absolute value of u plus c, or absolute value of z cube plus 1 plus c. Now I will take u to be 1 minus e to the power u, because the derivative of u, or du, well, it is u, so I will call it w. It is, he called it u, so I will call it w. So dw would be, the derivative of 1 is 0, negative e to the power u du. I have eu du, I need a minus sign. So I will have negative dw, and 1 minus eu is w square. Now this would be written w to the power negative 2, and the integral would be w to the power negative 1 over negative 1 plus c, minus with minus plus. So this is 1 over w, but w is 1 minus eu plus c. Here u is 1 over x inside sine, because du is negative 1 over x square dx, and it is already there, but I need a negative sign. So it would be negative. Now sine 1 over x is just sine du, and negative 1 over x squared dx is du. The integral of sine is negative cosine u, okay, plus c. So I will have positive cosine u or cosine 1 over x plus c. Try always to find the derivative of this to check your answer. The derivative of cosine 1 over x is negative sine 1 over x times the derivative of 1 over x, which is negative 1 over x squared. Negative with negative cancels, and you get this one. I take u, the denominator, 3t squared plus 6t minus 5. du would be 6t plus 6 dt. Well, I have here t plus 1, but if you multiply by 6, then you will have 6t plus 6. So I have 1 over 6 integral. This would be du, and this is u. So it's 1 over 6 ln absolute value of u plus c, or ln absolute value of 3t squared plus 6t minus 5 plus c. I'll take u to be ln x. So du would be 1 over x dx. I have 1 over x dx, and I have ln x to the power 2, so this would be u squared, and 1 over x dx is du. So the integral is u3 over 3 plus c, or 1 over 3 times ln x to the power 3 plus c. I'll take cosine x here to be u, then du would be the derivative of cosine is negative sine. I have sine, I need a negative sign, so it would be negative. Negative sine x dx is du, and this would be sine of cosine, which is u. Integral of sine is negative cosine plus c. So negative times negative is positive cosine u, or cosine x, because u is cosine x. Here I will take u to be tan theta, because du is the derivative of tan, which is secant square theta d theta. And now I have secant square theta d theta, this is du, and I have tan to the power 3, but tan is u, so I'll have u to the power 3. That's the integral, and u is tan, so that's the final answer. I'll take u to be arc sine x, or sine inverse x. Remember, arc sine is sine inverse. So the derivative du would be the derivative of sine inverse, which is 1 over minus square root of 1 minus x squared dx. So this integral would be eu. 1 over square root times dx is just du. So that's the answer. And u is sine inverse x. Well, here I'll take tan as u, because du would be the derivative of tan, which is secant square x dx. I have secant square x dx, so this would be du. I have tan to the power 2, so this is u square. It would be u to the power negative 2, so this is the integral. I will write it negative 1 over u, but u is tan. I can leave it like this, or 1 over tan is in fact cotan. So I can leave it like this. I'll take u here to be arctan, or tan inverse x. The derivative of tan inverse is 1 plus x squared, 1 over 1 plus x squared, which is already there. So this would be the integral of arctan is u. So I have u squared, and 1 over x squared plus 1 dx is just du. The integral is u3 over 3 plus c, and it would be 1 over 3 tan inverse x to the power 3 plus c. Again, I'll take u to be tan inverse x, and du would be 1 over 1 plus x squared dx, which is already there. So 1 over x squared plus 1 dx is just du, and arctan x is u. So the answer would be len tan inverse x plus c. Well, u would be 5 to the power t. It's inside sign. Du, the derivative of 5 to the power t is 5 to the power t times len 5 dt. So I need len 5. So I will divide by len 5 outside, and inside I will multiply by len 5. Now len 5 times 5t dt is just du, and I have sine 5 to the power t, which is u. The integral would be integral of sine is negative cosine plus c. So the final answer would be negative cosine u is 5 to the power t over len 5 plus c. Try to find the derivative. Well, the derivative of this would be negative 1 over len 5. Derivative of cosine is negative sine, so it would be positive sine 5t over len 5 times the derivative of 5 to the power t, which is 5 to the power t times len 5. Len 5 will be cancelled with len 5, and we will have 5 to the power t times sine 5 to the power t. I will take u to be pi over x. The derivative of pi over x is negative pi over x squared. Derivative of 1 over x is negative 1 over x squared, and pi is there, it's constant, dx. So what do I need? I need negative pi. So here I will divide by negative pi. Now negative pi over x squared dx is du, and this is cosine pi over x, which is u. Integral of cosine is sine. u is pi over x. All right. I'll take cotan here to be u. The derivative of cotan is negative cosecant square x dx. I have cosecant square, I need negative. So negative cosecant square dx is du. And this is square root of cotan, which is the square root of u. U to the power half, the integral is like this. So the final answer would be cotan x to the power 3 over 2 plus c. I'll take u to be 2 to the power t plus 3, the denominator. The derivative of 2 to the power t is 2 to the power t times ln 2, and the derivative of 3 is 0. I have 2t times dt, I need ln 2. 2t ln 2 dt is just du, and this is u. U is t to the 2 to the power t plus 3. So that's the answer. Now some definite integrals. I'll take u to be 1 plus 7x, the radicand. So du, the derivative of this is 7. I don't have 7, I need 7. I have a definite integral, so I'll change the limits of the integral of the integration. If x is 0, I put 0 here, so 1 plus 7 times 0 is 1. If x is 1, then u would be 1 plus 7 times 1, which is 8. So I'll have 1 over 7 integral. 0 is replaced by 1, 1 is replaced by 8. 7 dx is du, and I have cube root of 1 plus 7x, which is u. This would be written as u to the power 1 over 3. So u to the power 1 over 3, if you add 1, 1 over 3 plus 1 is 4 over 3, over 4 over 3, or times 3 over 4, from 1 to 8. So this would be 3 over 4 times 7, 28, times 8 to the power 4 over 3 minus 1 to the power 4 over 3, which is 1. This would be 8 to the power 1 over 3 is 2 to the power 4, which is 16. 16 minus 1 is 15. 3 times 15 is 45. So that's the answer, 45 over 28. And once you have a definite integral, you can check your answer by the calculator. I'll take u to be 2 plus square root of x, the radicand here, because du would be, the derivative of 2 is 0, the derivative of square root of x is 1 over 2 square root of x dx. And this is here, but I need 2 here, so 2 outside. And now if x is 1, u would be 2 plus square root of 1. And if x is 4, u would be 2 plus square root of 4. So the answer would be 2. If x is 1, u is 3. If x is 4, u is also 4. I have square root of 2 plus the square root of x is u. 1 over 2 square root of x dx is du. This is u to the power half. So it would be u to the power 3 over 2 over 3 over 2 or times 2 over 3 from 3 to 4. So it's 4 over 3 times 4 to the power 3 over 2 minus 3 to the power 3 over 2. Okay, this is 4 to the power half 2. This is 8. Okay, but this is not an integer. So I leave it like this. If you want, this is the exact answer. If you want, you can write an approximation. Okay, you can use the calculator. 3 to the power 1.5. Okay, and the answer would be approximately 3.74 if you approximate to 2 decimal places. I'll take u here to be ln x. Everything is fine, but I need to change the limits from x to u. So if x is e, u would be ln e, which is 1. If x is e to the power 4, u would be ln e to the power 4, and that's 4 because ln cancels e. So e goes to 1, and e to the power 4, we change it by 4. 1 over x dx is du, and this is square root of u. It would be u to the power negative half. So the integral would be u to the power half. Negative half plus 1 is half over half or times 2 from 1 to 4. 4 to the power half is 2. 1 to the power half is 1. So the answer is 2. I take u here to be x minus 1 to the power 2, all the power of e. And let us see whether the derivative is there or not. What is the derivative of this? Using chain rule, this is 2 times x minus 1 times the derivative of x minus 1, which is 1, times dx. Well, I have x minus 1 times dx. I need 2. So it would be half. If x is 0, u would be 0 minus 1 square, which is 1. If x is 2, 2 minus 1 is 1. Well, I'll have integral from 1 to 1. Two x minus 1 dx is du, and this is e to the power u. But since the integral from 1 to 1, so the final answer immediately would be 0. Some additional exercises. Well, the derivative of x plus 2 is 1, and I have x here. So this integral is not usual for us. Because the derivative is not outside, we have more than the derivative outside. But substitution will solve the problem. If we take ux plus 2, then du would be dx, because the derivative of x is 1. And now pay attention. I need to change everything from x to u. I have x here. Well, from here, I can find x. X would be u minus 2. And this would be square root of x plus 2, which is u. And dx is du. Now, is this an easy integral to find? And the answer is yes. So this was difficult for me because I have two terms inside the square root. But here I have one term inside the square root. So I can simplify this. How? U to the power half can be multiplied easily by u minus 2. So I'll have integral u to the power half plus 1, 3 over 2 minus 2 u to the power half du. The integral of this is u to the power 3 over 2 plus 1, 5 over 2 over 5 over 2, or times 2 over 5, minus 2. The integral of this is u to the power half plus 1, which is 3 over 2 over 3 over 2, or times 2 over 3 plus c. And now I can replace u by x plus 2. So this would be the final answer. It's a nice question, and it's different than all the previous ones. I take here 1 plus tan t to be u. Du would be, the derivative of tan is secant square. Well, do I have secant square here? I have 1 over cosine square. And 1 over cosine square is actually secant square. So now secant square t dt is du, and 1 plus tan t is u. This would be u to the power negative half. So this is the integral. And u is 1 plus tan t. So that's the answer. Well, first I will write this integral as sine 2x is 2 sine x cosine x. This is a formula. And now I'll take cosine. Well, I'll take 1 plus cosine square to be u. All the denominator. And let us see whether the derivative is there or not. The derivative of 1 is 0. The derivative of cosine square using the chain rule, it is 2 cosine x to the power 1 times the derivative of cosine, which is negative sine x dx. So this is in fact negative 2 sine x cosine x dx. Well, I have it there, but I just need a negative here. So if I call this I, then the integral I would be equal to negative 2 sine x cosine x dx is just du, and 1 plus cosine square x is u. So that's the answer. And I can replace u by 1 plus cosine square x plus c. Well, I'll take here u to be cosine x. Du would be the derivative of cosine, which is negative sine. I have sine, I need negative sine here. So this would be du over 1 plus u square, because this is cosine square. And the integral of 1 over 1 plus u square is tan inverse u. So the final answer would be tan inverse cosine x plus c. I'll take u here to be x square. Derivative would be 2x dx. So I need 2. Now 2x dx is du. And here I have 1 plus x to the power 4. Well, x to the power 2 is u. So x to the power 4 would be u square. Again, the integral of this is tan inverse u. And u is x squared. I'll take u here to be e to the power x. I have ex dx. Notice that e to the power 2x is e to the power x all to the power 2, because you multiply 2 times x and you get this one. I need to change the limits. If x is 0, e to the power 0 is 1. If x is 1, e to the power 1 is e. So this integral would be integral from 0 corresponds to 1, 1 corresponds to e, ex dx is du, 1 plus e x square. So this is again tan inverse u, but from 1 to e. So the answer is tan inverse e minus tan inverse 1. This is the exact answer. If you want to find uh, uh, an approximation, you can use the calculator. Okay. Make sure that you are in the radian mode. So the answer is approximately 0.4328. So I will write it 3. This was the last question. I hope you enjoyed the video. Have a nice time.